The browning of medieval stained glass windows. Between the artwork and the light, it is hard to resist the beauty of stained glass windows. Primarily used during the Middle Ages, stained glass windows illustrate local and biblical stories, a bit like a book. However, contrary to what you might think, stained glass windows do not last forever and they deteriorate over time. Sometimes discoloration is caused by dirt, which is easy to clean. But stained glass can also suffer an irreversible change of colour, which is much more problematic. Valentina is a researcher at the Geomaterials and Environment Laboratory at the Francilian Institute of Applied Sciences, where she also teaches. A specialist in cultural heritage materials, she is focusing her research on a particular phenomenon. The appearance marks are a real mystery on the surface of stained glass. We don't know how or why they form, nor do we know how long the discoloration takes. All we know is that they contain the chemical manganese. To understand Valentina's work, we need to know a little about medieval glass and the atomic structure of glass. To produce glass, you must melt sand, which is mainly composed of silica. Silica has a very high melting point, so other compounds or melting agents are added in order to lower this temperature. In the medieval era, the ashes of ferns and beechwood were used as melting agents. The mixture of silica and melting agents is then heated to roughly 1300 degrees Celsius before being rapidly cooled. Medieval glass has a natural greenish colour because the raw materials used contain iron impurities. In order to obtain other colours, a variety of compounds can be added, and this is where manganese comes in. By adding a little manganese, the glass becomes colourless, and with a little more manganese, the glass takes a beautiful purple hue. These pieces of different coloured glass were cut, sometimes painted, and then put together with lead to create stained glass windows. Now let's look at the atomic structure of glass, which is based on a network of silicon atoms connected together by oxygen atoms, called the vitreous network. Within this network, the atoms are arranged irregularly, which gives glass a disorganized structure. The vitreous network is modified by other atoms such as potassium, sodium or calcium, which derive from the melting agents, and these can break certain bonds between the silicon and the oxygen. These atoms are called network modifiers. This is what the structure of glass looks like when it is completely new. However, through contact with water, the surface of the glass can be transformed. Hydrogen atoms from the water molecules penetrate the glass and take the place of some of the network modifier atoms. These atoms thus free themselves and rise to the surface of the glass, and a porous layer, called a weathering layer, is formed. This is what sometimes happens with manganese, but when it rises to the surface, it tends to concentrate in certain zones of the weathering layer, creating these famous marks that preoccupy Valentina. The stained glass windows are thus speckled with ugly brownish spots. Valentina's first task is to understand how the manganese reaches the weathering layer and why it concentrates to form brown marks. Is it a physical, chemical or biological phenomenon, or maybe all three at the same time? To try and answer these questions, Valentina is going to carry out several experiments. Thanks to previous studies, researchers are aware that microorganisms can play a role in the weathering of inorganic materials. Certain clues indicate that these marks could be caused by bacteria that use the manganese. To check this hypothesis, Valentina starts by taking samples from the surface of medieval stained glass windows. While examining them, she does in fact find bacteria, but also microscopic fungi. Right now, she has decided to concentrate on the bacteria. To start with, she must know a bit more about the composition of an altered stained glass window. Since she cannot cut off a real piece of stained glass, Valentina will carry out tests on manganese glass that she has made herself. At first, she subjects the glass to different forms of alteration without bacteria. She is thus able to estimate the influence of the chemical and physical factors irrespective of the biological factors. Then she looks at what happens with the bacteria. After several days, she analyses the distribution of the manganese. Has it remained in the glass? Is there any in the water? Has it been incorporated by the bacteria? Have they produced brown compounds? If so, how? Is it the same phenomenon that takes place on the stained glass windows? She doesn't know yet, but intends to find out. In the long term, her work will shed new light onto these extremely complex phenomena and will doubtless enable the creation of some means of restoration and protection for stained glass windows.